Uh, this is a recording of the 10th grade geometry lesson, and it's definition. Chapter 1, Definitions and Construction Strategies. So let me help you with that. Definitions and Construction Strategies. Definitions and Construction Strategies. That's chapter 1. Yes, this is chapter 1. Then take it a little bit down. Or don't take it down. Alright, okay, it's chapter 1. And let me write here chapter 1. Chapter 1, Definition and Strategies. And what I'm going to do here is defining terms. Defining terms. Yes. Okay. So, chapter 1, Definitions and construction strategies, and we are going to do the defining terms. Let's move on. And what else? Yes, so let's start with the point. It's a tiny dot. Okay, basically point is a tiny dot. Point that is a tiny dot. Like this. Okay, basically point is a tiny dot. Like this. Okay, you put a dot, that's a point. And a line is a collection of points that are side by side, going on forever. A line, collection of points. Collection of points. Okay, side by side. Side by side, going on forever. Okay, that's a line. So how can we draw it? Or maybe do we have geometric shapes here? Yeah, this is a line, okay? Like this. So it's a collection of points. Or maybe this. Okay, you see, they are the collection of the points. Let's move it a bit down. And so, yeah, also it has no width, no height, etc. And it's 1 point wide. Okay, collection of points you put. And what else? And I have a plane. Plane. That is the set of points. Plane is the set of points aligned. Set of points aligned on a flat surface. Surface. Okay, that's a plane. For example, this the screen of this computer is playing. Yeah, maybe a rectangle. Anyway, so these are the plane. Okay, can be a rectangle. Line segment. A line segment has 2 points and they have the end points. Okay, so let me show you. I'm trying to use my iPad to show some drawing here. Okay. So a line segment would be like this. Okay, and it has 2 points. This drawing is ugly. I don't like it. So let's continue with the usual one. Okay, I'm going to erase it. Nope. Yes. Okay, so line segment, do we have shapes here? Yes. A line segment is something like this, and it has 2 endpoints. Okay, let's say one endpoint is here, another endpoint is here. That's called line segment A, B. And array is something like this. So this is a line segment, and this is a line, and we have an array. Oh, sorry. We have an array something like this. Yeah. In fact, we can draw a line segment maybe like this, so that you see the arrows. An array maybe like this. I want to do something like this, and we will have C and F, let's say. So when you show the line segment, so it's basically AB is a line, and this is array. Okay, it has like this. So from C to the F, and you do something like this arrow. Okay, and perpendicular lines are like when these lines cross each other 90 degrees. Okay, that's called perpendicular. This is not exactly 90 degrees, maybe this one is. So this is called perpendicular. You have the 90 degree here. Okay, and parallel lines, they never intersect each other. So two parallel lines. Oops. Yeah. So yeah, AB, and let's give them a name. MN. Okay, so AB, this AB and MN are parallel, and their distance is always the same. Let's say they have the distance D here, and the distance same D is always there. Okay, so even if you continue this line, even if you continue to draw, you will get the same D all the way along. They never intersect each other, okay? And distance between 2 points, when you calculate the distance between 2 points, you take the absolute value of those. So how can I show you? Let me do something like this. So we have a line like this, and what's this? And then let's point. So basically we are using the absolute value when we are doing the distance calculations, because distance is never going to be the minus, it's always plus. I'm opening the whiteboard here. Okay. So distance. So let's say this is 0 and 1, 2, 3, 4, and it goes on like that. And so it goes up this like that. By the way, let me check. Recording is okay. Stop recording. Everything is fine. Okay. And we move down -1, -2, -3. It goes on like that as well. And so when we are measuring a distance, let's say from P, let's say that's P, and Q to the point Q, okay? So P, distance PQ would be like something like this, PQ. So we take the absolute value of that, okay? Let me change the color to something stronger. Or like this. So that would be P minus Q or Q minus P, it doesn't matter. Let me show you. P minus Q. So what is P? That's -2. Okay. So -2 -3. Okay. And that is going to be -5. So absolute value of -5 is 5. Okay. So the distance between, basically, so the distance between this. So the distance between P and Q is 5. Okay, and it doesn't matter if we P minus Q or Q minus P, because we take this absolute value. And again, let me show you this with another. So let's make it Q minus P. Q minus P. So that's Q is 3 minus, okay, and -2, that's P. So you see, 3 minus -2. So here we have 2 minus, and when 2 minus, it becomes plus, okay? So 3 added by 2, we get the result 5 again, okay? Let's move on. Yes, vertex, side, vertex, angle. Okay. So angle is something like this. angle is something like this, and so angle is, let's say this is alpha, okay, these are the rays, and x, y, z, let's say, let's name them as x, y, z. So this is x, this is y, and this is z. So this y is called, this is the vertex. Okay guys, this is called the vertex. And we have the sides like xy and yz, they are the sides. Let's make them as a line. So when you show it, you show it like this. So yeah, y to x, but on the top you have something like this arrow. So from y to the x and from y to the z as well. Y to z, and again on the above you have something like arrow, so from y to z, and those two lines or rays share a common intersecting point, and that's called the vertex. Okay, and this is, yeah, we can denote this angle alpha. It has also another name, like you can show it in other ways like this. X, Y, Z, triangle. Oh, it's not exactly a triangle, but you put this thing which shows the angle, or you can put something like this. This is also showing the angle from starting from X, go to the Y, Z. Or you can do the vice versa. You can start from Y, Z, and then you go to Y, and then X, and then you put something that denotes. So basically, this is the denoting that this is an angle. Okay, Z, Y, X. So you need to start from one place, go to the vertex, and go to the another side. Okay, what else? Oh, we have a circle. Circle is something, you know, circle. This is a circle, but it has the center. Yeah, it has the center here, radius. Okay, let's give it a name O, and it has, so it's a set of lines and all, oh sorry, a set of points or small dots, all are the same fixed distance from the center, and that's called the radius. Okay, so this is radius, this is radius, okay, this is radius. It's like a pizza slices. Okay, so it's a pizza and you slice it up to the, and each side is radius. And also the portion is called arc. Let's say this portion. Okay, let's give it a name A, B. So we have A, so with the lines we show straight, yeah, but here we have arc. We need to do something like this, similar to arc. Okay, And we have AO, that's a radius. So let me write that here. So AO is radius, that's equal to BO. Okay, you see AO is this and BO is this, radius. Okay, so what's the difference between a line and a segment? A line is forever, it goes forever, but segment is, so let's move on. So let's say line is something like this. It goes forever to the each side. Okay, so this is a line. And we have a segment. Segment is like this. It's also similar to line, but it has ending points like this. R, S. Okay, that's the segment. This is so exact. This exact part is called the segment. RS segment. Oops, sorry for my bad writing. How array is different from a line and a segment. So array has one finishing point. So that's a full segment. Now let me draw array. So from F to P. So from F to the P, that's array, okay? Sorry. Yes. In fact, it needs to be continuous. Yeah, exactly. It needs to be continuous. We don't have this. Okay, so it's a straight array. So we give the name, but it's continuous. But it's a segment. So two ending points, two dots. But here we have only F and to the side P. Okay. Also, it's called the FP. Let me write it like this. F from F to the P, and we put the arrow. So arrow needs to be like this. It starts from F to the P. Okay. Let me give you an example. Basically, we have a line, let's say, and it's divided into some parts. Let's divide it into some parts like this: 0, 1, 2, 3, 4. So -1, -2, -3, -4. It goes on like that. And we have 2 points on it. So M and so let's say PQ -1 and 3. -1 and 3. So we have the P on -1 and Q on 3. What's the distance between PQ? Yes, what's the distance between P and Q? So how would you do that? You take the absolute value, and so it's like this: absolute value P minus Q, or you can say the both way, Q q minus p, because you take the absolute value. As long as you do that, the distance is going to be the plus. So p is minus 1. Yeah, so let's do this one first. Minus 1, q is 3. q minus p, 3 minus 1. Okay, so what do you see here? Two minuses. What do? They will eventually become a plus. Okay, so this side is minus 4, but and this side is 4. Okay, so when you take them out, both of them are going to be 4. 4 equals to 4. That's it. So the distance between P and Q is 4. And we have another exercise. R. Find the place of R, so that, where is R located? So that RP equals to PQ. Yes. RP equals to PQ. Yes. Okay. So let's find it. So PQ is 4. So R can be in place of Q. We can write here R. Yeah, we can write down R here. But also, we can move to the left side. Yeah, even though the indicators, the numbers here are minus, the itself is not minus because that's a distance. So minus 5, and it goes on like that, minus 6, etc. So we need to move to the left and find 4 distance, okay? 1, 2, 3, 4. Now you see, you reach to the 5. Oh, sorry, minus 5, okay? So R needs to be here. R. Yes, R needs to be there. What else? Yeah, why the center of circle is not part of the circle? Because when you draw a circle, the center is always at the same equal distance from the outer part. So let's say center is around here. Over again, it always has the same distance to the other side. Use this one. Yes. Okay, so this is R. This is R. Wherever you go. Okay. So if you include this as the edge or the outer circumference of a circle, no, it's not going to be circle because it's a central point. Like there's a central point, like this clock. Okay, there's a central point, and all the distance is equal. All the circumference is the same distance from the center, radius. Okay. And we have another question. So let's say O has a circumference of 252 centimeters. Okay, its full circumference is 252 centimeters. All these outside of the circle. And it says we have a pizza slice like this, and it has the right angle, let's say KL, okay, KL, and find this arc of KL. How would we do that? So we have, if we get this full, we'll get four similar slices, let's say. So let's say we are asked to find x, so it will be x also, this is going to be the x, and this is also x. So 4x equals to 252. And we need to divide 252 into 4, and we will get x is equal to, what's 1/4 of the 252? 200 is 50, 52 is 30. Yes, 50, 30, 63. Okay. Am I correct? I hope I am correct. Okay. So this x is 63, or you can say KL arc. It's not a line. Okay. KL arc equals to 63 centimeters. Yeah, that's all. We have recorded like how many minutes? I don't know. Can I see somewhere? I don't know. Anyway, thank you.